Hi everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. As we launch into 2025, this week we're diving deeper into the outage trends we've seen in 2024, in particular a notable amount of configuration change related outages, and the steps IT teams should take as a result. We'll also discuss recent incidents at OpenAI, Google Cloud PubSub, and Netflix. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco Thousand Eyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. Let's start with a quick recap of the 2024 outage trends we observed for ISP and CSP outages. On our last podcast in mid-December, we noted some key shifts for cloud service provider outages and internet service provider outages. Now that the final 2024 numbers are in, we can confirm that those trends did indeed hold. While ISPs still account for the majority of outages, as they have in the past, the percentage of CSP outages significantly increased. In 2023, the ratio of ISP to CSP outages was 83-17. In 2024, that ratio rebalanced significantly to 73-27. That means the percentage of CSP outages has risen from 17% to 27%. For more on what might be causing this shift, see our last episode. We'll include a link in the show notes below. Mike, we also saw a theme in 2024 of configuration change related outages. What might be causing that?
A couple of trends we can probably put it down to, or we can actually link it to there. The first one is if you think about how the applications are sort of pushed out, they work on this continuous improvement, continuous delivery. So this is a central theme in software engineering. It helps works. It helps enable faster deployment. You can push updates out because you're working on sort of small modules, as it were, within the actual code, as opposed to actually doing what was traditionally done was a waterfall where you push things out. So although this allows these rapid updates to work, what it also have is you basically have multiple different teams working in individual areas. So they're sort of working on a particular part of the code or a particular feature. And if we think about how the applications are sort of distributed and we're working on all these different dependencies, there could be this possibility where things interact. You don't know effectively, the left hand doesn't know what the right hand's doing, if you want to put it in that vernacular there. So we can make a change that has an unknown effect. So although everything's working in our area, we could actually sort of have this change in the downstream component or a component we didn't know about. You can actually do tests and you can actually work out what's going on within your module. And they will have all unit tests when they sort of build these up. They're putting a patch on or something like that. But as they start to roll these out, you don't necessarily know what's going to have the impact down on the other area itself. So these sort of fast rollout of these services can actually start then to potentially sort of lead to these changes. The other thing you can think of in this system is because we have these vast systems, we have all these multiple things put in place, we have a lot of automation taking place. So we'll make a change, there'll be certain jobs that are running. Now, if these two instances start to coincide, again, without understanding specifically what the potential is, if I make a change here, what's the impact across the entire system? There could be a job going on at a particular time that is doing a perfect function, or we could be doing some maintenance role where we're taking a system down. We're taking a container from a healthy to an unhealthy state, so it's not available at that moment in time, or we're making a change of software patch to a load balancer, for example, at the same time that coincides where one of these pushes is being done. Now, also, because the automated systems have this flow on action, if I see these set of conditions, we're going to take a particular action. Now, if there's something that they're not necessarily expecting, or something occurs within that, we have a domino effect taking place. And their action, because of there's been a separate change or another job running at that time, they could take an action that could actually then become sort of detrimental to the performance. So although the automation is very good, because we're starting to spread around these areas, and although you're not necessarily looking for configuration issues within that particular component itself, it is this compiling or this compounding of one automation kicking off another automation, kicking off another one, at the same time as a change taking place at that time.
What steps do you recommend IT operations teams take to guard against outages related to configuration changes, or to mitigate their impacts when outages like these do happen?
The changes themselves, there's quite a lot of unit testing going on at that time period. So we do a unit test, everything works. Nobody's essentially pushing out code that they know they've got a bug in. If you think about some of the issues we have there, they have sort of latent bugs that's triggered by something else across there. So although these unit tests take place, if we can actually look at that entire service, so instead of looking at discrete components, if we start to consider this where we're looking at right across the portfolio, we're looking at a service itself. So what makes up that service? Now, if we do that, if we then start to look at particularly when we're making a change or about to push something, if we're able to test that at the same time, i.e. the entire service, you then have a better understanding. You don't necessarily need to look into all the change configuration windows or these types of things. I can see instantly, I've made a change and there's been some sort of detrimental effect now. Once we do that, then you know what steps I need to take. Have I reached a point where I could roll back my change? Or is it too late to do that? Therefore, we need to sort of mitigate there. But it's all about getting visibility into that impact of change across services. As we talk about from an overall perspective, dependencies that you don't control or you don't own, you can't instrument. It's the same even if I'm looking within an application that we own. One particular group, we're looking at one area itself. So if I can actually look at that holistically, and then I can understand, okay, I've made this change and really do something very simple, almost like a spot the difference. So if I can actually understand, okay, I've made a change and this picture has changed across this area there. If I think of the each component there almost like a discrete component, and if I'm looking at a test that goes right across those, I don't necessarily need to understand what's actually gone wrong, or that helps me make those steps. It's really understanding that a change I made over here has an overall impact to the service, and therefore then I can actually take the actions I need to take.
Thanks for that overview, Mike. And for folks who want to hear more about 2024 outage trends and lessons learned from some of the most notable outages of 2024, you're welcome to join us on January the 21st for Thousand Eyes' upcoming Top Outages of 2024 webinar. We've included the registration link in the description so you can check it out and sign up. We look forward to seeing you there. OpenAI experienced an outage just after Christmas Day. Tell us more about that one, Mike.
So it was right after Christmas Day. It was December the 26th. And OpenAI services, so we're thinking of things like ChatGPT, Sora, and their associated APIs that make the calls. What happened is it experienced an issue that was due to a power failure at a cloud provider's data center. So they haven't actually said which there, but it was a third-party sort of data center where there was a power failure. Now, how this manifests itself is the user sort of face internal server errors. Luckily, because of the holiday timing, the actual impact, the visible impact it would have been sort of reduced around there. But the outage lasted nearly 8 hours during the day Pacific time there, which would raise concerns for the operation teams from the OpenAI themselves. Actually looking into this, I said, with this power failure, it actually took one of the databases down within the cluster itself, and this had this impact around all the clusters themselves. So although the databases are globally replicated, the region-wide failovers weren't actually sort of had to be manual intervention. They couldn't actually do them. So during that period, it extended that mitigation time. Although they identified specifically what the problem was, had this power failure, then because they actually couldn't get in the databases there, things were actually sort of locked. They couldn't then do the failover to kick things over that point.
OpenAI's incident report said they were unable to restore full performance until the cloud provider had recovered from its power failure. Explain why, in these days of database replication, it's not always as simple as switching to a different region to maintain service performance.
This is kind of a good one, really, in that what it actually allowed OpenAI to actually find out in this case was they had something of a single aggregation or a single point of failure within there. So if we're thinking about a database and we're thinking about sort of the complexity that we have or the size we have with things like ChatGPT to run all those models there, we have to run this across a distributed architecture. Now, that means we have to keep these databases sort of replicated at all time. If I have something in one of them and I'm relying on one particular one there that sort of goes out, what I can actually start to do is sort of cause locks in that system. So I'm actually causing a lock in there, and therefore then I actually can't get into the rest of them. So if I have a dependency, as it were, on a main database in this instance there, then it can actually cause this flow-on failure itself. So obviously replication is good because I want to be looking at the same set of data each time I actually go into there. But if for some reason I'm unable to replicate, what normally would happen is I then go into this lock situation, or that one gets taken out and we sort of replicate the others there. But if one of them is in essentially sort of the core or the heart of this, then I start to get this situation where I actually can't. And therefore then we can't get in and we can't do a failover to sort of bring the other ones back up online.
On January the 8th, Google Cloud Pub sub-users were impacted by an outage. What do we see there, Mike?
When we're talking about pub sub, we're talking about publish and subscribe. So pub sub, and it's a messaging pattern. So what it allows to do is to sort of categorize the message. Now, if you think about sort of a message queue, where I'm actually sending stuff to a specific area, or I requested a subscriber where I send that, what it actually does is it categorizes it and sends it to all of those who are interested in that particular class. So I said it's a middleware system, or it's part of a middleware messaging system itself. And it's often used with queue models, so like a JMS, a Java messaging service itself. And it provides this asynchronous communication with latencies around sort of 100 milliseconds. So it's suitable for things like streaming analytics, data integration, service integration, and task parallelization, because I'm not necessarily relating for that one-on-one type of synchronous remote procedure calls or things like that where I'm coming down from there. So what happened then? This was actually a misconfiguration itself. So the Google Cloud experienced misconfiguration, and it lasted around sort of 1.25 hours and impacted things like the cloud logging, the BigQuery data transfer services, and it was across multiple regions. The Google engineers traced the root cause instance back to a bad service configuration change. They make a change to it and then made to a regional database that stores the information about the publishing of those messages. So the pub sub, so the publishing of the messages, and the order in which those messages were published, so the order from delivery. So effectively, rather than sort of getting them out there, we start to have this issue where the configuration change sort of unintentionally over-restricted sort of the permissions to access a database. And this was then rolled out to different databases. The fact then this message couldn't get out, we sort of got this block there. Google said that the problem was not picked up in pre-production due to a mismatch in configuration between the two environments. So why the bad configuration change was actually rolled back, there was a latent bug itself that led to a prolonged duration while they were sort of trying to make further repairs and pull these things out.
Google's report said there was a notable delay in log exports as a result of this incident that may have affected customers' ability to monitor and respond to events in real time. Explain what impacts that might have had on customers and if there's anything customers can do to mitigate such events in the future.
It's all about this, how we get the message to ourselves. So we think about this as a messaging queue system. So if we're thinking about the analytics or the information we're coming out from there, we're thinking about using things like log files themselves. So the data will get written in and then it comes back for this type of information. If I have a delay of actually getting that to me, what it actually looks like is that I haven't actually received those log files. So in some cases, I wouldn't have got them. But if we think about a log file, it's after the effect. Something happens, get it in log file, then it comes out. So I'm already starting to have this delay. So I actually can't respond. So the point of it is I might not have actually realized there was something wrong, or I realized something was wrong because the service wasn't working, but I couldn't actually get the information out to understand what's happening. So if we think about what we could do in this situation, we can almost think of like a belt and braces type of approach. So again, by looking at a service from a holistic perspective, if I can understand, is there something going on with that service? Is there performance information? I'm effectively sort of doubling up on my telemetry that I'm actually getting out of my analytics stuff I'm actually getting out from there. So I'm looking at what's my overall service and then where's my fault domain I need to drill down in. If I could just see what's going on. Think of it like the situation we sometimes see with status pages, where the information is sort of written into a status page and you go into there and straight away you can see users are having problems, they're starting to complain. And in some cases, we look at this and it's all green, everything's on there. And it's not until sort of 5 or 10 minutes after there, or sometimes longer, where you actually start to register that there's an issue and it shows up on a status page. But effectively, it's talking about doing the same thing. So rather than getting your log files, you have something over in place there where you can see what's going on at the overall service. What that does is alert you to what's going on, so you can actually take the steps I need to do. So I say identify the fault domain where we have this problem and therefore what issue we're going to take in place. One of the things to remember here is you're not necessarily going to get away from all of these things. These will happen. These aren't nefarious. There's necessarily people doing these misconfigurations on purpose. And we've talked about this concept where we have them rolling into each other, this domino effect from there. But the whole key to this is that if you accept that this will happen, what you need to do is to reduce that impact. So what is the impact that I'm going to have on my users or on my brand or whatever it is you're actually looking from there? And then by understanding what's happening and where my fault domain is, it does two things. One, it allows me to get the right mitigation or the remediation steps in place, but also offers me a situation, if we think about the OpenAI one, for areas where I can optimize. This was a single point of failure. How can we optimize this so we can learn and move forward from this in the future?
We briefly covered the issues Netflix experienced during its live stream of the Jake Paul versus Mike Tyson boxing event on an earlier podcast. But you've been digging deeper into the streaming performance on the night, Mike. What have you discovered?
So we actually started looking at thousand-eyes tests. We actually test specifically to look at the stream performance itself, and we identify some latency issues and some error spikes during the event, which also correlated with what the evidence was being said in terms of people seeing pixelation. They were seeing a disruption within the image itself. Now, the errors themselves sort of varied by region. So if we're looking at within the Australian ISPs, we saw sort of issues almost throughout the event itself. Whereas within the US itself, we had ISP problems. We saw some congestion across different ISPs, mainly at the event start themselves. If we look across different ISPs, different regions, and then we sort of saw a common theme across all of these. And the common theme was in the Open Connect appliances, which is Netflix's own CDN. If we look at this and take this from a lesson for everybody else, if we think about what we're doing there, we got to consider the architecture itself. What's the content we're trying to serve from there? So you can actually take sort of lessons from this. And the fact I specifically called out the Australian ISPs there is because there's some commonality around sort of time of day. So when we think about the content that we actually push out to the Netflix or Netflix pushed out to themselves, they're loading it onto these CDNs. And they also load on at the same time, they were loading on all the catalog of information. Now, how this information is actually pushed out is based on a time period local to the local time zone itself. And this is typically done between 2 a.m. and 2 p.m. local time. So if we look at the time the event occurred, we also saw this was right in the middle of their load time for these Australian, New Zealand OCAs, when it's actually doing this fill time as it was. We're actually putting the whole Netflix catalog for that particular region on at that time. So therefore, again, what we're looking at is combining these signals together. So we could see the congestion. We could see it wasn't unique to an individual ISP or particular region. So therefore, we could see it was actually, in some cases, limited time of day. What else is going on at that time? And this is what we can actually see happening.
Explain how Netflix's Open Connect appliances work and why streaming live events places different demands on them to regular Netflix streams.
It's different demands in as much as we're looking at doubling the content, as it were, at that particular time. So if we think about the nature of a live event, people got upset if there's a break either in the audio or the video from there, or pixelation. If you get kind of choppy, you might miss some sort of critical event around from there. But this isn't the first time Netflix has done sort of a live broadcast there. And I said their architecture is actually set up to do that itself. So how they actually set things around there is they have these Open Connect appliances, which are essentially Netflix's CDN. And they provide these to ISPs from a local one, because we actually all want to be close as you can, or internet exchange points where sort of the ISPs come straight in. So the point is you can actually get this information as quickly as you can from a latency perspective, because everything is effectively local to you. Now, that is actually delivery of the service itself. Everything in the back end, so pre-play activities, so including when you do your discovery, the transcoding of the analog to the digital, all these types of stuff is actually done in the back end service. Now, Netflix use Amazon, so AWS services do that. If we actually sort of then look at that content, I've got to go through and do my transcoding. I have to send that information and send it out. Now, the regular content itself is sort of preloaded into the OCAs during these off-peak hours. That was that fill situation I talked about where we had the local time from 2 a.m. to 2 p.m. And this is typically done at off-peak hours. So I wouldn't normally have this situation occurring there. While a live stream is going to require real-time processing. So that event's happening. I have to take that in and do the transcoding at the same time and actually then push that out. This isn't the first time that Netflix has done a live broadcast, and we sort of see more. I don't necessarily think there's anything specifically wrong with their architecture. It's just these sort of competing things that sort of took place at the same time.
For more insights on these Netflix issues, definitely check out our blog post, which we've linked in the show notes below. Before we wrap up this week's show, let's take a quick look at the outage numbers we've monitored through the end of December and the early part of this year.
So we're looking at a 4-week period here where we're looking at sort of different trends. So total global outages showed a downward trend initially, dropping from 205 to 197, which is a 4% decrease in that first week. And then we saw a significant decline in the second week, with outages dropping from 197 to 76, which is a 61% drop. Now, this trend actually reversed in the third week, where outages started to rise up again. So we saw from 76 to 148, which is a 95% increase, and then doubled again in the fourth week to 296. The US outages experienced a slight increase in the first week, then a dramatic decrease from 111 to 28, which is a 74% drop in the second week there. Now, the US outages then fell into this pattern again, where they actually started to rise in the following week. So 78, which is a 179% increase, and then to 117, which is a 50% increase. Now, if we think of that time period we're actually coming into sort of the December 23rd, 24th, 25th was when those numbers dramatically declined and we saw that number going off, which is to be expected, really. If we actually look at that from December the 16th to 29th, we had a 51% of all global network outages occurred in the US. Now, this was down from 58% in the previous period. So if we look at the percentage then of outages from the US, we actually saw that last period there, it sort of sat at 44% of total global outages, which sort of brought the average of 2024 around to 42%. Now, this was an increase from 38% in 2023. And as we've seen consistently for this year, where we've seen these US outages accounting for at least 40% of global outages. Then because we had the year end there, if we looked at December, we saw a total of 724 global outages, which is a 14% decrease from November's 840. And the US outage decreased from 501 to 408. This is typical. We've seen over the previous 3 years. If I go back over the numbers, coming into December, I see these numbers actually drop.
That's our show. And don't forget, for more on outage trends and lessons learned from some of the most notable outages of 2024, you can join us on January 21st for the Top Outages of 2024 webinar. We've included the registration link in the description, so definitely check it out and claim your spot. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it, and not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on LinkedIn or X @thousandeyes, or send questions and feedback to internetreport@thousandeyes.com. Until next time, goodbye.